So, thank you for joining us on this month's edition of TeK-ToK by TBC-InTV. I'm John Tuck, and I'm a holistic energy scientist representing Silent Koala. I've got over 20 years of experience in the energy storage and energy generation industry across the range of technologies from commercially available products to blue sky innovation. I work predominantly in intellectual property for a battery manufacturing company in the UK. This month, we've got two Alexes on the call. Alex Koizikov and I have a special guest from Litium, a company in the UK, who provide warranties and insurance to manufacturers and end users in the energy storage arena. Alex Johns has a wealth of experience in the battery industry and provides a global perspective on the industry as a whole, and in particular, the nuts and bolts surrounding rollout of batteries within the electric vehicle sector. So once Alex Koizikov has briefly introduced himself, we'll hand over to Alex Johns of Litium to do the same. And then we can have a chat about things like British Volt and what we think might have gone so badly wrong for them. So over to you, Alex Koizikov.
Yeah, thank you, John. Great to be back on TeK-ToK. I'm Alex Koizikov, co-founder and CEO of Natrion. Natrion is a solid-state battery startup based in the United States, in upstate New York and the Chicago area, where we specialize in developing technologies for battery manufacturers that allow them to transition to safer and higher performance solid-state battery designs, both for current lithium-ion batteries as well as next-generation lithium metal batteries and other chemistries. And we started about 4 to 5 years ago. I started this company right out of college with my co-founder, Tom. We've since grown to about 16 people, have 2 locations, and just last year raised a $2 million round of funding with some investors, including Mark Cuban, who is pretty famous in the States. I don't know if you folks in the UK know him, but
we know of Mark Cuban.
Yeah, but over to you, Alex Johns.
Thanks very much, Alex, and great to meet you. And John, good to see you again. So I'm Alex Johns. I work for Litium. Litium is what they call an insurtech. So it's a sort of a high-tech version of an insurance company. And we specialize in batteries. So we're kind of the meeting point of lots of battery knowledge, lots of data analytics knowledge, big data, and insurance knowledge and experience of the insurance markets and how to do warranties and so on over many, many years with renewables and before that heavy machinery and so on. So it's pretty specialized stuff. And it's important because if you think about it, the insurance companies who are our partners have got some of the strongest balance sheets in the world. If they start lending, in inverted commas, their balance sheets to support battery assets, whether it's the manufacturers or whether it's the owners or whatever, then that is putting financial weight behind those batteries, which allows for mass adoption. It allows for finance and all the other bits and pieces, which really like insurance to be there to give them that confidence of strong balance sheets. My own background is quite mixed, that I've worked in the mobility space for about 15 years, give or take, looking at innovative mobility projects. I've looked at, in particular, some shared mobility projects, which have been taken forward by some much larger companies. And I ran one of the first electric vehicle taxi pilot projects out of Gatwick Airport, where we took some Teslas and we put about 100,000 miles each year on each car for 3 years. So not many people sort of basically take a Tesla and work it that hard. And they coped pretty well, actually, surprisingly well, how well certainly the batteries coped. Other bits fell off, but you expect that. So yeah, I came into this in terms of the insurance space better part of 3 years ago now, and brought that experience of the sort of the voice of somebody who'd done it on the practical end, which is sometimes missing a little bit from some of the conversations when you're developing new products at a sort of financial instrument end. But anyway, good to be with you guys, and yeah, let's have a good chat.
Yeah, thanks very much, Alex Johns. That was a great overview. Thank you. I think we've worked together for the past 3 years, I expect.
Yeah, give or take. Yeah.
And you appreciate the very long journey it is to developing this type of technology. I mean, I guess if it was easy, everyone would be doing it. It's really not easy. And warranties and insurance play some of the final parts and stages in actually getting your batteries to market, your cells to market. Hence why we've been talking for so long. So Alex Kozakov, do you have any questions for Alex, or should we dive straight into the whole current world news on British Volt, for example?
Yeah, I don't think so. I think I actually haven't had a chance to read what you wrote up, Alex, on British Volt yet, but would love to hear your take. Because yeah.
Well, British Volt is an example some people may have heard of. So it's this battery cell manufacturer that set up a few years ago, appeared from sort of nowhere, and attracted quite a lot of investment from Saudi Arabia. They also got some good supply deals and investment from Glencore, and they made a lot of progress. Now that's actually was particularly impressive because they started with nothing. They didn't start with a load of intellectual property. They didn't own any cell technology. They didn't own any land. They didn't own anything. They came together with a patriotic sounding name, probably more attractive to the London markets than calling it Saudi Volt. And they managed to raise quite a lot. I think it was, John, do you remember how much it was? Was it 100 or 200 million, something like that?
Something like that, yes.
Yeah.
Similar,
and they made a lot
I
of
think,
progress.
to North Volt and Ital Volt and
Yeah,
all of the others, but yeah.
exactly. So they made a lot of progress. They changed their minds a couple of times on their sites, but they ended up with a site up in the northeast of England, which actually was extremely well situated, that it was close to sort of roads and trains, but more importantly, it was just inshore from a very, very large wind farm. So not only would there be plenty of water and power, but also there is, of course, the big power connectors to the grid, which is absolutely essential and not an easy thing to get. It's an area with sort of some deprivation, and so would attract some support from the government. They managed to get the government to agree that they would come up with some support, although they didn't actually do so, or they would do so at a later stage potentially. But anyway, they basically, what they needed, apart from what they'd already achieved, was to get somewhere with the intellectual property and development of some cells, and I believe they have. They they took the Tesla idea of 4680 cell and decided to put a slight twist on it, so it became a 4690, I believe. I saw a prototype of one of them, which it made me chuckle, but I thought, well, why not? And I don't know the exact chemistry of that, but I assume it was some kind of high nickel NMC, and that I think they were looking at dry electrode rather than solid state, but I'm not certain of that. I don't think anything much was released. But I think where it went wrong was the fact that they couldn't attract substantial customers, because they were talking about quite a lot of gigawatts of gigawatt hours of production each year, for which you need large scale manufacturers as your sort of core clients. And with the UK situation, that the only large EV manufacturer to have committed to high volume production is Nissan, and they take their cells from AESC who are almost co-located with them further north and the northeast. And so that market, if you like, wasn't available. That's already tied up. So every other manufacturer is a bit of a niche, really, that there's some sports cars, there's some racing cars, there's some this, that, but not the high volumes that you need to justify the couple of billion they would need to build this facility. So without that, the investors decided they wouldn't spend some more. Also, asset prices have collapsed in high tech and EV stocks. So it's basically they ran out of money. They did get a reprieve for a few months. Someone chucked in a bit more to give them a chance. The government didn't dip in their pockets, but I think their pockets in the UK are pretty empty anyway. And so it's in administration. Now, there's been some bits in the press about the administrators, which is EY, trying to find buyers who are used to dealing with distressed assets. I would say it would need somebody with more specific competency and experience than just a distressed asset sort of company. But anyway, so that's the context. Does that sound like a reasonable summing up, John?
Yeah, absolutely. And I think when I first considered British Volt, my main concern was that, unlike anti-power, for example, who have taken the technology from the ground upwards, British Volt seemed to have, as you've suggested, approach it from the top downwards. You know, as Alex Kaiserfeld and myself are very much aware, developing cell technology is not a simple thing, and there are several main challenges which are involved. And firstly is supply chain, which it sounds as though they'd really thought about, and they'd managed to position themselves pretty well. The other is existing manufacturing superstructure. So again, they were in a good position for that. But the key element, as you mentioned, was that they had no existing technology. You know, and one of the significant challenges in any scale-up operation is the scale-up itself, as both Alex and I are acutely aware of. I think when I've seen so-called gigafactories being considered by companies in the past, what tends to happen is that they realize that actually they may have bitten off more than they can chew, and they tend to take it in more gentle steps towards what are microlines or mega factories before they would even consider to go to the gigafactory scale. So, you know, I think the endeavour that British Volt made was really quite remarkable. I do hope that somebody's able to pick it up and run with it and perhaps salvage the great work that they've already done.
In the little article or sort of think piece I put up on LinkedIn a couple of weeks ago, I sort of posited a way forward, which kind of builds on what you've just said, that the EV market, I think they're not going to get these massive EV orders, because I don't think the UK is going to get the massive EV factories, frankly. So I was thinking, okay, why are they aiming for that? You know, that is the flashy bit of the market, and about, what is it, 80 or 90% of cells are going to go towards EVs over the next 10 years, but the rest are going to go into stationary storage. And now, if you look in the stationary storage market, and I think you guys are probably keeping a bit of an eye on it, and we see a lot of it coming through because of the insurance and warranty side.
Yeah.
That if you want to buy a stationary storage, you've got at least an 18-month lead time at the moment.
Yeah.
You don't necessarily even get a price on day one, because prices are moving so fast. They say, well, when you get to the top of the queue, then we'll tell you the price.
Yeah.
So clearly this is a seller's market. You have none of these issues about high performance power to weight ratio and all of that, because it really doesn't matter what they weigh. They're only going to sit there in a big box. They haven't got to drive around. So you don't have to have these very high nickel or high manganese cells or cobalt or whatever, you can run with the much cheaper and relatively simple LFP cells.
Or even progress towards sodium ion, which would be perfect
Indeed.
for
Sodium ion,
application.
which is even better from the fire risk safety point of view. So given that, it struck me that there is probably an opportunity to either license or buy some technology simply to make some suitable cells. They don't have to be cutting edge for stationary storage. They need to be good enough.
Yeah.
And then potentially vertically integrate from day one the cell through to the BESS, which some companies are doing and some aren't. But you could potentially buy one of the ones which is got a very full order book, but is quite small. And I know of one or two, but they better remain nameless, where you just buy the company and that gives you an instant base on which to build. Then you can build that up. I would start with the grid scale stuff. Then I would go to the domestic scale. Can do some, but keep the number of products down to an absolute minimum, make it as easy as possible on the manufacturing front so that you can get scale with as least headaches as possible. And then because we're kind of late to the high power market, skip the intermediate technology. By the time these guys are ready, it'll be too late. So go straight to the solid states if you want to go for the higher power and EVs and things like that, or even aircraft or whatever. But if you like, that to me would be a recipe for something that could come together quite quickly, something that could start at a medium scale and grow bigger if you want it to. Would probably be worth a look. But that was just my tuppence worth. I don't know what you guys think about that.
No, absolutely. It's interesting because Alex and I, our guest last month, or Alex, was it end of last year when we had Ian Faulkner?
Yeah.
Yeah. So we had a guest, Ian Faulkner from Scotland, who's addressing the interim problem by importing stationary energy storage from China. And wouldn't it be great if we could have that kind of facility to provide those products in the UK? And do you have suppliers in the US, Alex, who are offering stationary power for consumer applications, local storage? Sorry.
Yeah. Yes, I think stationary storage. I think very similar kind of situation here where, right, like LFP. As far as lithium-ion battery technology goes, LFP of course makes the most sense for stationary storage. But about 95% of LFP cells are made in China right now, and that's going to go to 99% pretty soon. And LFP isn't really very developed out. The manufacturing of it, at least outside of China. And so you end up with, at least in the U.S., a lot of a lot of great things like second use of old EV battery packs and so forth. But it really seems like stationary storage is going to become dominated, at least in the U.S., by alternative chemistries, especially things like zinc. So a lot, at least in North America, especially in Canada, a lot of fantastic zinc battery technology companies, a couple in New York as well. Just it's really tough to beat zinc on dollars per kilowatt hour with lithium ion, because zinc is at most going to be like $50 per kilowatt hour, whether it's zinc nickel, zinc or some other zinc manganese dioxide or so forth. It's going to require, at least in the US, it looks like it's going to require some of these alternative chemistries, the manufacturing and the supply chain to develop for those. But once those take off, it'll be that industry is going to look pretty independent from lithium ion. And at least in the US, I think lithium ions can be for the most part bound up with EV manufacturing.
So would you maintain your path of pursuing more of the EV in terms of the solid state cells that you're producing?
Yeah, no, well, at least I didn't actually know this. That was a very interesting point, Alex Jones, about how, yeah, at least in the U.S. there is a lot of domestic EV manufacturing being built up, especially because of the infrastructure, or rather Inflation Reduction Act and so forth. The IRA, of course, Europe's now trying to figure out a response because we're actually stealing some some talent and projects from Europe as a result of the IRA. Yeah, so it's almost like every other week there's some announcement of a new joint venture for EV cell manufacturing in the U.S., especially all through the Rust Belt and the Corn Belt. So for us, yes, it makes sense, but at the same time, the scales and kind of harkens back to what Alex Johns was saying about fundamental issues with British Volt's model, but the skills you have to operate in order to be relevant in automotive are immense. So for example, we make a solid state component technology. We don't make full battery cells. We just make an electrolyte component, and 1 metric ton of our material, we're thinking right now about scaling up and going to pilot production. A metric ton of our material will only be enough, will only make enough battery cells for about 70 electric cars. That's a metric ton, right? So it would be a bit of a suicide mission for us as, for Natrion as a company to just outright go after EVs and not pursue any kind of niche stepping stone markets in the meantime. So what we are doing is also branching out into consumer electronics, power tools, drones, much smaller end use case applications where we can get some early traction and revenue before we're fully prepared to do something meaningful in automotive, because there's really no way to just go straight after the automotive industry.
Yeah, no, that's a really good point, Alex, and it makes me consider my comment that the only way you can really scale up is doing it in small chunks. But is there actually any middle ground between small scale production and vast scale production, if vast scale production is what is required? So I think it's a very challenging situation, and I guess could be best remedied with just a lot of money poured into it and a lot of interest.
Well, I think, John, that I completely hear what you're saying, and it's actually when I came into the insurance industry, I noticed insurance and batteries seem to have something in common, that their scaling doesn't just go up in 10, 20% or whatever, it goes up in orders of magnitude. And there's not a lot of difference in the sort of development work you have to do for something which is going to be in the kilowatt hours as to something that's going to be in the gigawatt hours. And so, that's not unusual for insurance across the piece. Once you've got a model that works, you can take it to scale, massive scale, very quickly. I was very interested in Alex, your comment really about the Inflation Reduction Act, or the Reinflation Act, as it might be called, and the Europe's response to that, which is I think posited. I don't think it's yet completed, but of course the UK is out of both of those. So we have found ourselves in funding no man land with a country which hasn't got a lot of money to sort of to compete with that sort of level of subsidy, for want of a better word. And I actually worked better part of 20 years ago for a regional development agency, which is a government agency when they existed. They don't exist anymore. And learned quite a bit around the purpose of subsidy. And I think there's been a lot of talk about subsidy for British Volt, and a lot of sort of little bit of bitterness that the government didn't come up with some money to help them keep going. And actually, it's not the role in a free market economy of governments to come in and build the business case, as it were. They're there government money is there to unblock blockages, really, and to help sort of oil the wheels a bit. So you could say, well, they weren't oiling the wheels, they hadn't come up with anything. But if you're relying on them to make the case for your business case, then you're going to struggle anyway. You really need to have a business case that's robust. And hence my comments saying that, okay, if they had a big client who they knew were going to buy gigawatt hours of batteries every year, then you can forward finance that. There's plenty of finance in the markets if they're confident. And that, again, swings back to that whole balance sheet protection, insurance finding ways of coming in with different warranty or insurance products. And British Volt just couldn't get anywhere near that, unfortunately. But I think they could still do it. I hope that whether it's the Saudis or Glencore or someone has a look at this and goes, actually, you could buy a best manufacturer, you could buy a license for some LFP or some sodium ion or whatever, both of which you could have where you're buying it with a known asset base, so that's relatively easy to finance. And then if you're buying something with an order book, and that certainly the best companies I know have an order book, then you've got something to build on. But anyway, that's coming away from that. What I would love to talk about, and I don't know whether it's a bit of a repeat for you guys, but I would love to know more about the solid state technology, because I'm quite used to the lithium ion and the various different cathode materials and so on. But I would love to know more about what is the difference, if you like, in the engineering of a solid state battery. Why is it different to, say, a dry cathode, a dry electrolyte, which you might come across now, and does it still degrade? And what are its fire properties like, and all those sorts of things. And yeah, I'd love to know.
Yeah. There are a couple of different approaches towards solid state batteries. I think, broadly speaking, kind of every company, and there are a lot of companies working on solid state right now, which, is a great thing, but broadly speaking, you could kind of, put each company into one of two buckets, which is, folks working on what are called organic materials, which are polymer electrolytes, and those that are working on inorganic or ceramic electrolytes. So, the inorganic materials are probably more prominent in both academic literature and in commercialization cases. So, for example, QuantumScape and Solid Power, pretty well known at this point. Both of them are working on inorganic solid state battery solutions. Now, the reason ceramic or inorganic solid state batteries are promising is when I say ceramic, these are the way these materials look and feel and behave, it's like a ceramic. They make these kinds of they make these thin sheets of the material, and it's you call it potato chip quality, right? Because the thing can just crack and snap in your hands, because it's like a ceramic, like what a pot is made out of or whatever. But the reason people are so excited about ceramic or inorganic electrolytes in particular is because they have really, really fantastic performance. So you can really push charging speeds way past what current lithium-ion batteries are capable of. They're very thermally stable. So these materials are the materials themselves are put together at temperatures of 1000 C or so forth. So they're going to be fine until then. But the only challenge is really the processing, and how do you get that into a battery cell and make a battery cell work with that in the center of it? Because it's very difficult. While it's easy to move lithium ions inside of a ceramic material, it's very difficult to transfer lithium ions from cathode or anode to the ceramic and vice versa. So that's really the challenge, and that's why QuantumScape and Solid Power and other companies working on technologies like these have evolved into full-fledged battery cell manufacturers of their own, because they've had to completely redesign how the battery cell is built, and it looks nothing like the process that a Panasonic or an LG currently uses to make a regular lithium ion battery. So that's really the processing challenges. And I mentioned there are also people who work on organic or polymer chemistries, and that's really the flip side. So when you use a polymer material, the processing becomes really easy, making the cell becomes really easy, but at the expense of performance and at the expense of a lot of the safety that you could gain with the ceramic material. So I would think of a polymer as kind of a middle ground between traditional lithium ion and ceramic solid state. But that's I don't know, John, is that a good gist?
Oh, absolutely, and I'd also add to that what you're developing is a slot-in solution to conventional manufacturing technology. So there's no additional equipment required in terms of the manufacturing process. It simply slots in place of the existing electrolyte solution, and the only thing the things you're further tweaking are already being considered, such as the material for the anode and other components, which then facilitate the higher rates of charge discharge, power density, along with the energy density. So, really very attractive solution. I guess we can be clear that it's not quite absolute solid state, is it? It's still an interim solution, but I think what you've done is to combine the best of both of the organic and inorganic materials in order to provide an excellent solution. And as you said, one of your challenges is in allowing the ions to pass from the electrode into the electrolyte itself.
And
Yeah.
just to come back on a sort of follow-up question, does it work in the same way as having a cycle life such that they will degrade in terms of their state of health over time, or is it just that the cycle life's much longer, or is that just not a relevant question?
It depends. So yeah, again, varies from to a great degree cycle life. It's to a great degree battery cycle life is perhaps more dependent on battery electrodes than your choice of electrolyte, with some exceptions. But yeah, in general, it is possible, and people have demonstrated polymer solid state batteries with traditional graphite lithium ion battery anode that have as much cycle life as if you were just using a conventional liquid electrolyte. It certainly is possible. I think one of the other exciting, perhaps the most exciting aspect of solid state technology, though, is it allows you to, as John mentioned, implement other materials at the battery electrodes. So in general, solid state is seen as a bridge from traditional lithium ion to something like lithium metal, where instead of using graphite on the anode side of the battery, you're using really pure elemental lithium. The advantage being that lithium metal stores about 10 times more lithium pound for pound than graphite can. So you can make a huge leap in the energy density and how much energy you pack pound for pound. Now, when you do solid state with lithium metal, cycle life is the biggest challenge. And that mostly originates from just how complex of an anode material lithium metal is, not so much something intrinsic to the electrolyte, but it's the electrolyte that we end up having to engineer to have to make the anode work, if that makes sense. So yes, as John mentioned, it's what we're trying to do at my company Natrion is kind of take a stepping stones or iterative approach to this, where we're not jumping to all solid state, and we're not making we're not making huge changes to the battery electrodes quite yet, or the battery cell assembly process quite yet. We're trying to keep as much of the original lithium ion battery manufacturing process intact as we can, and specifically produce technologies that the large manufacturers who have been, making battery cells in gigafactories using the same process for the last 20 or 10 years, that they can implement to start migrating towards solid state and towards lithium metal batteries and so forth. And what we're doing differently, more specifically, is that we have our material is a composite solution. So we use both inorganic and organic material in our solution. But the cells that we're currently working on, they're not all solid state. We're still using a little bit of liquid in the battery cell, just because it's there's like I said, trying to take an iterative approach that manufacturers can follow much more readily, rather than trying to make some leaps like some other companies are in this space. But
yeah, no, I think that it's also worth pointing out, and as far as I'm aware, Alex, correct me if I'm wrong, there aren't any companies who produced a commercial total solid state product anyway. So, you're not behind anyone in that respect. You're actually quite far ahead of many of the companies in that respect. So,
yeah, it's interesting. So there are all these kinds of you have to look out for if somebody says they're solid state versus all solid state, because if somebody says they're just solid state, that usually means they're using some amount of liquid. Even for example, QuantumScape, who have made incredible technology progress, they're still using liquid on the cathode side of the cell, just because it's you open up a whole new can of worms as soon as you try to replace all the liquid in the cell. But if you can make a big enough reduction, like even as much as a 20% reduction in the volume of liquid that you're using inside the battery cell, can make a tremendous impact on the flammability and making the cell much safer at a more intrinsic level. So
yeah, I think safety is also one of the very key elements of solid state, Alex Jones.
Yeah, I mean, it's going to be fascinating putting my sort of insurance hat back on. So if cycle life is a challenge, then warranty is going to be important, performance warranty. So if that's the you can have all the performance in the world, but if it drops off quickly, people are going to want to know how quickly and how can I hedge against that, if you like. And so that'll be really interesting to have those conversations. But the other side of it, away from warranty, is insurance, and with sort of operational all risk insurance, which is a sort of annual one, a bit like your annual insurance on your car. That covers things like fire as the big risk. And if the fire risk is dramatically reduced, that is a great thing, and will bring the premiums down and make them easier to insure. So yeah, it's going to be interesting to as these products get closer to market, to work with the manufacturers and the designers to then be able to model out their behaviors and performances, to then be able to price those in the risk.
Yeah, because it's not an easy process to gather copious amounts of data in order to be able to write an insurance model. So
insurance wordings are extraordinary, and if ever you suffered from a lot of insomnia, just start reading through your insurance wordings and you'll drop off. Absolute treat. But I have to say that I have a little weakness, that I do actually quite like maths and statistics, and so getting into the guts of how to price the risk, which is of course the core of what the whole insurance industry is about, I find absolutely fascinating. And when you start looking at, okay, so what are the distribution curves of performance of these batteries? How are they varying? What's the mean standard deviation? Is it behaving like that? And then working out, okay, so what are you scaling off? And then what are your different factors affecting that? And so it's brilliant. It's brilliant. I can't do it all myself, but it's watching the actuaries do it is like watching a sort of surgeon at work or something. It's absolutely stunning what they can do with the maths.
Awesome. Well, thanks very much. I mean, we've come to the end of our 45 minutes. Is there anything else you'd like to ask, Alex Koizikov, with Alex?
Yeah, I don't know. I just, I suppose I'm curious about one thing, which is, you know, that one thing about uh, battery chemistries is that they can, the way that the conditions under which they are used can dramatically affect how they're going to perform and how long they're going to last. And in particular, I think, yeah, I keep reading that something that people are finding is EV consumers are really terrible to the EVs in the sense that they charge them to 100% state of charge, they discharge them down to, you know, past 30%, and then they wonder why they're not getting as much mileage as promised. So I'm just curious, kind of, is that something that has to also be addressed on the insurance side? Is that more a responsibility for OEMs? Is that consumer responsibility? And how is that going to evolve?
It's actually a really big question. So there's a huge education piece to be done about what batteries can and can't do, and how to look after them. Because you're absolutely right that the difference between looking after a battery in a way that it quite likes, you know, cycling between 20 and 80% or something like that, and really taking it way too high and way too hot and way too low and way too cold and all those sorts of things, can be 400% in terms of the life. You know, instead of it lasting 5 years, it might be 20 years. So there's a huge variance, and that people don't understand. They don't know what treating it right is, and what not treating it right is. And you can imagine, from a risk management point of view and a risk pricing point of view, if your asset might last 5 years, might last 20 years, how do you price that? So we've come up with some very innovative ways of doing that, where we I'm not quite sure how much I can say in public, actually. Basically, we worked out methods of doing that where the user still has the flexibility. This is particularly when you're talking commercially. The domestic user, you just kind of have to take a view, and think that it'll balance out over enough people, and then just keep putting enough information out there in the hope that people sort of educate themselves a little bit as they go along. And of course, it's complicated because it's different in terms of the way you look after, say, an LFP battery than you do an NMC and so on. But on the commercial applications, with a stationary storage, you know, you can go from a little bit of you go from a backup battery situation where most of the time it's doing nothing, to at the other end of the spectrum, you could be doing commercial arbitrage, buying and selling in and out of the market on small changes in the price of electricity, doing loads and loads of cycling, sometimes very shallow, sometimes very fast, whatever. And there's lots and lots of different applications in between, and they have huge effects on the lifetime of the battery. But in essence, you can set some parameters around temperature, around C rates, around the number of cycles, and so on, and then use that to price variations in the risk. I'm not going to go into probably more detail than that, because we've got some quite clever mechanisms which gives people the flexibility to not only change their minds, but also they might sell the unit, whatever it is, and somebody else use it in a completely different way, the new owner. So, you know, you do need to have a flexible framework, and we've got that running now, and it's working very nicely.
Awesome, thank you, Alex. Does that answer your question?
Yeah, that's very interesting. Thank you. Yeah.
Yeah, really good question. There's so much to consider in all of this.
Yeah, absolutely.
Right, okay, guys. Excellent discussions. Thank you so much. We'll be back next month with a new edition of TeK-ToK by TBC-InTV. Once again, thank you, Alex Johns. That's been really interesting.
Thanks, John.
I'll see you next time, Alex Koizikov.
Yeah, sounds good. Yeah, good to meet you, Alex Johns.
Cheers. Thanks a lot.
Thanks, guys.
Bye.
Yep.